Hello, in this presentation, what we're going to do is we're going to show you how you can use Bill's box to solve for the amount of product you can make from a chemical reaction. In this case, we're going to burn propane, which is C38H8, and oxygen. After that propane goes through combustion, as you can see here, we got a picture of a common propane oven fire that is a fire pit that people often have in their backyards and so forth. We have that there. When this happens, carbon dioxide is produced and water vapor is also produced. And what we're going to do is see theoretically how much of this would be produced if we were given a certain amount. In this case, we have 5 grams of propane and 6 liters of oxygen. So we're going to be looking at how we have to make, what adjustments we have to make when we solve a problem like this. And we're going to use Bill's box to do that. A system that I highly recommend, because if you follow the system, it's pretty easy to get your what your product is, and you can then figure out your percentage yield and so forth. The very first thing we have to do, though, is we have to make sure that our equation is balanced. And if we look up here, we see that our equation isn't balanced. So we're going to come down here. I'm going to grab my pen, and we're going to balance our equation. I've already done this, and in this equation, we need 5 waters. So I'm going to put a 5 as a coefficient there. And in terms of carbon dioxide, we need 3. These numbers are going to be important when we go and use our mole ratios. And over here, our waters are 4. So I've already balanced this equation beforehand. So we're going to use that when we get into solve it down here, when we have to figure out what our ratios are and what we're doing. Our equation we can fill out in here. So this is just simply the equation that you see above. So we have the C3H8, which is the propane. And then we have the oxygen. And again, there is a coefficient in front. So we'll put that in there just so in case we have to remember that that coefficient is going to be used in our ratios. Our product, we're looking at how much water we're producing. So that's going to be our main product that we're looking at. So I'm going to put that water here. And we're not doing much with the carbon dioxide, so I'll just put it down here and I'll leave it there. Because the question asks you about the theoretical yield of water, how much water we would actually produce. So we have our amounts. We have 5 grams of the propane here. So we're going to put 5 grams here. That's what's given in the problem. And then we have the 6 liters of oxygen. So 6 liters here. And now we have to convert, anytime we want to figure out what our product is, we have to convert it to moles. So in order to convert it to moles, we have to use conversion factors. The conversion factor for grams, is molar mass. So we need a molar mass calculation here of propane. So we put molar mass. I'm just going to make a little note of that for that one there. So we're going to need the molar mass of the propane. Over here, we are given liters of oxygen, so we can use our volume for a mole conversion factor, which is a standard amount, which is 22.4 liters per mole. So we have that as our standard amount for any sort of gas, and so we can make that calculation there. I've already calculated the molar mass of propane, and it is 44. This is, again, use the periodic table, 0.11. We always round to the nearest thousandth, grams per mole. Now, when we come down these columns, you have to figure out, well, what mathematical calculation would provide moles? If I multiply, I'm going to get grams squared, which would be really weird, and that's not what we want. So the best thing to do here is to divide. So as we go down, we divide by the amount by our conversion factor. So that's going to be key that we do that. So if we divide the 5 divided by the 44.11, I'm going to put that in my calculator here. 5 divided by 44.11. I get 0.113, which I can just round that to the nearest hundredth again, and that would be just 0.1111 mole. And that's going to be my first mole there of the propane. That's how much propane I am given. So 0.11 mole of propane. Now the other one is I take the 6 and I divide it by the 22.4. And I get 0.267, so that rounds up to 0.27 mole. All right, so we have our moles that we've used there. Now, we got to see how much product we would produce. Both of these, we're going to have different mole ratios to get to our product. We have the blue one, which is for going from the propane to the water, and we have the red arrow going from the oxygen to the water. So we have to see how much we would produce. Well, what's the difference between these two arrows? Well, it's the ratio of the product from the reactant. So we're, for every four moles of water, it takes 5 moles of oxygen. So the red arrow, which I can put here, the ratio is 4 mole of water over 5 moles of oxygen. So that would be my ratio on that line there. For my other line, for my blue line, going from the propane to the water, it is 4 moles of water for every 1 mole of the propane. So this one is a little bit different ratio. This is 4 over 1. So those are the ratios there. And that goes into these two things here, these two parts here. We could write that. But that's kind of what we have in terms of our mole ratios for this particular thing. Now, if we do these calculations, we'll get our product. So we can compute our product for each of these. If I take the 0.11 and multiply it by 4, I get 0.44. So this one right here, I'm going to get 0.44 moles of water from that propane. And then if I switch to my other one, okay, so that's 4 over 5. If I take the 0.27 and multiply by 4 and divide by 5, I get 0.22. I get 0.22 mole of water with the oxygen. Now, one of these is higher than the other, so that tells us what limiting is. Because I only can make 0.22 moles out of the oxygen, this is all I can produce. So this is my limiting, this right here. This is my limiting reactant, and that would be limiting is oxygen. So we put that down. So that reactant is only going to provide us with 0.22 moles of water. So this is limiting, and this would be excess. We would, we would produce more with that. So we can only go with what is limiting in terms of what we're going to do. Now we have to go up and see what my yield of water is, and it's going to be in grams because it says that's what we're probably going to be looking for. We could say the water vapor too. We could convert it in that, but let's do a mass. So if we're going to do a mass, this final answer here is going to be in grams. So we have our grams here. Pen is giving me some problems, but there we go. So in order to do that, again, we need a conversion factor. We're going to need the molar mass for water. And the molar mass of water, well, oxygen is 16 plus the 2 hydrogens. We know that's 18. Basically 18 grams per mole. And if you multiply, so now we're going up, and since we're going up Bill's box, and again, if we want to get rid of moles, we're going to have to multiply. So there you go. So 18 times the 0.22 is our next calculation. And that gives us 3.96 grams of water. And again, if we use a different conversion factor, we could calculate how many liters of water are produced or how many molecules of water if we used Avogadro's number. So there's a lot of things that we can do, but we would be able to produce only that much water. If we collected it, it would be 3.96 grams. So our theoretical yield of water down here is the 3.96 grams. Well, let's say that I only was able to collect 2 grams. So let's say that I only collected in my, flask or whatever I was using 2 grams, 2.0 grams. We could then calculate our percentage yield. And remember, percentage yield is actual over theoretical. So we take the 2.0 and we divide it by the 3.96 and we multiply that by 100. So if we do that calculation, 2 divided by 3.96 equals, and that multiplied by 100, you would get a 50% yield, 50% percentage yield. And so that's how you would calculate that as well. Again, remember that these numbers here, the blue one is 4 over 1. That's what this would be here, 4 over 1. And then this mole ratio going from the other reactant is 4 over 5, just again, so we know that what those mean. So if you see a slide like this, you know how to fill those out. Obviously, I wrote everything in here by hand, and you can type these things in. But again, this shows you how we use Bill's box to solve for percent yield, theoretical yield, and we can use this to go the other direction too. So if we were given a product, we could reverse this. And remember, mole ratios, it's always what direction you're going to and where you're coming from is how you use those mole ratios. So if you have questions, feel free to let me know. But otherwise, good luck with solving any stoichiometry problems and using Bill's box.